First one we're going to talk about is a merge sort. If we're to have the following numbers 4, 2, 1, 6, 3, 5 and the merge sort algorithm is shown below, what we have to do first is take this one single list and make it into small individual items. So we split it up and we end up with 6 small lists. What we do next is we merge each list with the adjacent list. So we've got 4 and 2, they merge together, but they merge together in the correct order. Next we have 1 and 6, they merge together, they were already actually in the correct order, and the same for 3 and 5. We now have 3 merged lists. So let's ignore the original ones, just concentrate on our 3 merged lists. And what we do is we repeat the same again. So 2, 4, 1 and 6 will get merged together. Now what it does is it actually looks at both lists and the algorithm actually just finds the lowest one, which is 1, then the next lowest one, which is 2, then the next lowest one, which is 4, the next lowest one is 6. It merges them all together so that when we repeat it we end up with a single list of 4 items. We then repeat that again by merging those 2 lists, the list of 4 items and the list of 2 items, and we end up with a single list of 6 items. Now we have a single list. Our sort is complete. Let's see this in action with a graphical representation. The final sort is called a quick sort. Again we have our numbers of 4, 2, 1, 6, 3 and 5, and again we have written out the algorithm at the bottom. First of all we need to choose a pivot point. How well you choose this pivot point depends on how well the quick sort works. There are lots of different ways of choosing a pivot point, some to do with choosing average values or first and last values, mid-range values. For simplicity we're just using the first value in the list. This might work well, might not, depends on the data that you have. Now if we have this first item which is a pivot point, what we're going to do is we're going to then split all of the remaining values into 2 lists. One that is smaller than the pivot point, one that is greater than the pivot point. So if I place my pivot point there just in the center for now, I'm now going to choose all the numbers that are less than the pivot point, put them over on the left hand side, all the numbers that are greater than the pivot point, go on the right hand side. If you notice they're not in the correct order, they've just been transferred in the order that they are in the original list. They've just been split into those 2 sides. If we just ignore the original one, we look back at our current data, we're just going to repeat the above steps again. So we choose a pivot point, which is the first item, which is the number 2. We place that down out of the way. We look at the remaining numbers, which is the numbers 1 and 3. We split them up so the lower values are on the left, the higher values are on the right. We then look at the next one, which already is a pivot point of 4. We then look at the next one and we make a pivot point of 6. Place the pivot point down so we know where it is. All the lower values go to the left, all the greater values go to the right. We then loop around again. The first one is a pivot point, but there are no values to be placed above or below. The second one already is a pivot point. Third number we make a pivot point, but there are no values left or right to put in. Fourth value already is a pivot point. Fifth value becomes a pivot point, but there's no values to put in left or right. Sixth value is a pivot point. So we actually have repeated until all our values are now pivot points. If we've got to this stage, we just recombine the list because they should be in the correct order to find our final value list. And again, let's see this in action with a graphical representation. Hopefully that was useful. If there's any other topics you'd like me to cover, please post a comment below.